Grüß Gott, meine Damen und Herren. Hello, ladies and gentlemen. How many of you speak English? How many speak German? I'm wondering whether to give this presentation in German or English. Probably the Germans understand better English than the English-speaking German. Any preference? English? Okay. I'm going to talk a little bit about paper recycling and the problems that we currently have. My name is Axel Fischer. I work for an association of paper mills, and what all these paper mills have in common is that we de-ink paper. That means we remove the ink from waste paper, from recovered paper, in order to produce new bright paper. That can be hygiene papers, that can be newspapers like this. For instance, in this newspaper, this is made out of 100% recovered paper, 100% post-consumer recovered paper. And now you can imagine that this in Europe is an issue. A standard paper mill produces about 2,000 tons of paper every day, and this is a large volume. So I'm going to talk about what printers can do about contributing to this cycle. Every printer wants to become green, but it's not enough if you want the hood of your printer to be recyclable. You have to think about your printed product. What happens with the 10 tons of printed paper that leave your print shop every month? Look at that. We say printed paper has to stay recyclable, and what the paper industry does is cradle to cradle. Everybody talks about cradle to cradle. This is what we're doing. We're producing paper for newspapers from the same material. And there's hardly any other product where you have this loop as closely as you have in the paper industry. This is the paper loop. You have a loop from printing, collection, sorting, and then there's something missing. I'm sorry. That's the problem when you work with fruit instead of computers. So you have here paper for print, for newspapers and magazines. It's printed, it's collected, it's sorted, and from this cycle you have some exits. Go into waste, go into packaging, go into hygiene paper, which is not recycled. You have some losses, but you also have an incoming stream of fresh fiber. So this is what the colleague from SCA said before. Without incoming fresh fiber, you wouldn't be able to produce recycled paper. This is not a closed loop, it's an open loop with incoming streams and exits. So if you look into a paper mill, sometimes you see newspapers that are only 5 to 7 days old. So it's a very closed loop, and you always produce the same product again. So that is why we say we are doing cradle to cradle what everybody demands for more than 30 years. So how does this work? If you put your paper, your newspaper, into the paper collection, it ends first in the sorting plant, because a paper mill that wants to produce a newspaper cannot make a newspaper from brown fibers. You have to separate the board. You have to also separate plastic. You have to separate the dead hamsters. You have to separate the $100 bills, whatever is in your recovered paper, and what you cannot use to produce paper. And this is going partly mechanically, but the last step is always by hand. So these people at the conveyor belts, they do sort the last CDs, the last plastic out of this running stream. But what these people cannot do is separate by printing process. If you have unde-inkable prints, they cannot realize what is printed offset, what is printed flexo, what is liquid toner. You cannot do that in the sorting plant. This is why it is important to look already at the collection level. So what happens in a paper mill? This is the incoming station of a paper mill. It's like a paper mill is like a kitchen. You produce different products with different brightness grades, and depending on the brightness that you want to produce, you compose your paper mixture. If you want to produce a standard brightness like newspaper, you use standard recovered paper. But if you want to upgrade that, if you want to achieve a better brightness, if you want to make copy paper or so, then you have to add some, for instance, overprint from a printer. This is a more expensive raw material, and here you see this caterpillar. You mix that according to what you want to produce. Take household mixture for the basis, then you take some printer waste, which has a better paper quality, a higher brightness, to upgrade the brightness of your final product. So the first station in the paper mill is this drum here, a rotating drum where you dissolve the recovered paper and you create a fiber soup. It is 99% water, 1% fibers, and the fibers go through these screens here. They are washed through the screens in this drum to go into the next step of the process. And here at the end of the drum, all the leftover CDs and plastic bags and whatever is still in the mixture falls out. So if you have this fiber soup, then you de-ink it. That means you try to remove the ink from the fibers. And this separation process requires certain properties of your ink. It has to be hydrophobic. It has to feel the need to escape from the water, escape from the fibers. You want the hydrophilic fibers to stay with the water. You want the ink to escape. And for that, you add a little bit of caustic. You make this solution alkaline. You add caustic soda, and this slightly alkaline conditions make the fibers swell. And like my shirt, the ink bursts off. It's being released from the fibers, and then you add some soap. And the soap creates bubbles with air, and these bubbles go to the surface, and they are a taxi for the ink particles to escape from the water, because these ink particles, the offset ink particles, as I said, they are hydrophobic. They want to escape from the water. They take the chance that there's a bubble going to the surface, and then you get some foam that has all the ink particles in there. The ink particles are skimmed off from the surface. This process is repeated over and over in several steps until the foam gets brighter and brighter and the fibers get brighter and brighter. So here you see that in an actual plant. This is one of these cells after the other. Step by step, the fibers are cleaned. And if you look into here's a little lid. If you look into that, then you see the foam. Here is the ink. This is where we want the ink to go. And that might explain to you why water-soluble inks cannot be removed in this process, because they stay with the fibers. They do not escape with the foam. They are dissolved in the water and stay in this process. Here's an example before and after. This is the ink pulp, this is the ink pulp. This is how we want to clean the fibers in this process. Dry toners are good de-inkable. Why? They do that because you have particles. You have decent particles. They can be removed just like offset inks. They are hydrophobic. They have a certain size. They are not dissolved in the water. But the problem that we have is with water-based inks. If you have water-soluble inkjet, like this mailing here, somebody put a large cup or something on it, then you see the ink dissolves already with small amounts of water. Now imagine what happens in the paper mill. Here another examples for foreign newspapers. I have the actual examples here. If you put one drop of water on it, you see it bleed, or you see it bleed through. In this example, till page 7, one drop of water. Now imagine what happens when you dissolve the whole newspaper. It's like a sponge full of ink going into your system. And that is like, you might have seen our poster, it's like the red sock in the washing machine. Yeah, one red sock is enough to stain all your white underwear pink. Because small amounts of ink that get released into the water go onto the cotton fibers. And what is cotton? It's celluloses. Same thing as paper fibers. And in the same way, soluble inks also stain paper fibers. There's one difference between the washing machine and paper recycling. In the washing machine, you change the water. In paper recycling, we don't. For 15 years, we have closed water loops, one of the major environmental achievements of the paper industry. So if you have a closed loop and you add one sock after the other, the inks accumulate. And the only exit is the fiber, your underwear. So this is the question. Water soluble is not necessarily environmentally friendly in this case. I explained that. Prints with water-based inks are in the recycling process like the red sock in the washing machine. And here you see some example of the circulation water. It's really dark. And some people say that there is no problem yet. You can cope with a couple of inkjet prints, and we're going to develop that. We're going to develop a solution. The problem is here and now. Every paper mill today already struggles with brightness problems. You want to achieve a certain brightness. For instance, in the UK, you have flexoprints. You have already several challenges, and in the paper mills do not need any additional challenge. So every inkjet newspaper that is printed with water-soluble inks is one too many in the process. There is no buffer that we can accept yet. This is the reason why inkjet prints create problems. Here you have some test sheets from unde-inked an unde-inked product. If you dissolve that, you get these test sheets. You filter this fiber soup that I talked about, and then you get a test sheet. Before and after the inking, you see the ink is removed. This is, for instance, an offset or a toner print. You see an increase in brightness before and after the process in the lab. And here you see unde-inked and de-inked from a water-based inkjet print. There is no effect of the process because the ink stays with the water, it stays with the fiber, and it goes onto the fibers. Here's some examples where this is already used. These are, for instance, a famous German newspaper called Bild, and you've probably never seen a Bild Zeitung that is as pale as this one. Usually the red is has much more blood in it. And this is an inkjet printed newspaper as you get it when you're on vacation on Malta or on Cyprus. This is from Cyprus. Because earlier the newspapers were flown over to Cyprus. But then they were there around noon and nobody would buy them. And these papers are now printed on demand in Cyprus. They are delivered to the hotels in the morning, so they are at the newsstand in the morning when the tourists want to buy their local newspaper. And this is being printed with inkjet. And when this is the Versamark machine here, and when you de-ink it, this is one of our schemes, of our evaluation schemes. It fails in several categories. It is not de-inkable. We do not want these in the paper recycling system. The same is true with this. It's an OC Jetstream. It's a My News. It's a news on demand that is offered in Switzerland. It also fails in every category that is applicable for inkjet. The same thing here with some pigmented inkjet news that's on USA Today, an example that we got from another trade show like this one, and it fails in the de-inking process. So the inkjet inks today on the market in general create a problem in paper recycling. We do see some light at the end of the tunnel, we do see some developments, but they only possible with pigmented inks when you try to accumulate these inks to form larger particles that can be removed in the process. There's no solution inside with dye-based inks, and this is the problem. Today about 80% of the inks sold are dye-based. All these newspapers, all these mailings, they are printed with dye-based inks. The vendors offer the machines with different kinds of inks. It can be pigmented, it can be dyes. If they choose dyes, we have the problem. So there are examples of what can be de-inked. One example is the Fujifilm development, this jet press. What do? They coat their paper before printing the inkjet on it with some coagulant. It is being made to improve the image quality. But when you improve the image quality, you want to prevent the pigments from bleeding into the fibers, getting lost, bleeding into each other. So what do? You coagulate the pigments to form larger particles that stay on top of the fiber, and that makes a distinct image point. And this is a larger particle than the primary one. And if you create larger particles, you have a tendency to make them the right size that we can remove them in the de-inking process, that they are not the primary small ones that you cannot remove. And this happens, for instance, in this press. And the other idea to make inkjet de-inkable is to avoid water at all. And this is what Xerox does with the machine that's now called Cypress. This has no water at all. It's a wax type ink. It uses the same technology as inkjet printing. It's sprayed on the fibers, but there's no water. It's not water soluble. It can be removed in the de-inking process. So here we have good results when we test that. So, if you have any questions about that, I have a small booth here. I have some press releases. I have lots more information. I'm going to tell you how we want to get the ink here into the foam. This is where it has to go. It should not stay in the water. It should not go in your underwear. It should not go in the fibers. Help us to make prints sustainable. Help us to get the ink into the foam. Thank you very much.